First of all, thank you so much for the opportunity to come along and give you a little bit of insight into the topic of marine heat waves, and especially this summer's marine heat wave event. This has been quite topical this week because the Australian government has just released its first national climate risk assessment, which does mention marine heat waves and some of the impacts that it's going to have on the marine ecosystem. So I'll touch on that a little bit later on. So first of all, I'm going to just acknowledge the traditional owners and the lands that we're meeting on today, which is the Whadjuk Noongar people. I'm not quite sure you know, but the Noongar people have a 6-season calendar, and we're currently in the season of Jilba, which is essentially just describes that transition season from winter to spring and the contrasting weather patterns that we have, and this week is clearly evident of that transition season as we go into those warmer spring months. Okay, so let's dive into the topic of marine heat wave. Now, marine heat wave, as the name suggests, is largely to do with ocean warming. But ocean warming is something that's really hard to kind of visualize, right? So, you know, when you're standing at the beach, you really can't tell whether the ocean is warmer or cooler by just looking at it. So what we really rely on is satellite-based measurements and satellite-based imagery to kind of understand our ocean climate and ocean conditions. So that's what I've got up there. So this is a global map, sea surface temperature anomaly for the year 1980. So way back, about 40 years ago. And you can see on a global scale, the ocean, you know, dominates the planet. It's about 70%. And the largest of the ocean basin, it's right in the center, is the Pacific Ocean. And the Pacific Ocean drives one of a major climate driver that you probably all aware of is the ENSO. And it has 3 phases. And in 1980, you know, that we got a neutral phase there. We also have 2 other phases that you're also probably aware of. The cool phase of the ENSO is called the La Nina, and you can see that blue signatures coming through. And then the warm phase of the ENSO is the El Nino, right? So these 2 terms I'm going to use quite a bit as we talk about, you know, marine heat wave events. But I also want to draw attention to the fact that when the Pacific is in these 2 different phases, it highly influences what the ocean conditions are like off the west coast. So during a La Nina, when the Pacific is cool, we tend to experience warmer than average temperatures off the west coast. And the opposite tends to happen when the Pacific is a lot warmer in the El Nino phase. We tend to have cooler temperatures off the southwest of WA. Okay, so starting in 1980. So 1980 was essentially the start of satellite-based sea surface temperature observations. And this is quite a critical period or critical turning point in these measurements that now we're still using today to understand global climate and especially global climate change. Okay, so 1980 was also the year that I was born, and I was born in a little tiny nation called Sri Lanka, just south of India, just circled over there. And my family migrated to Sydney, Australia in 1988. In 1988, we've got, you can see I've just swapped the maps over. We can hear you now, Courtney, so I'll just let you know. Swap the maps over. We can hear you now, Courtney, so I'll just let you know. Swap the maps over. So I didn't catch any of that. Were you trying to? Yeah. So 1988 was another moderate La Nina event. So you can see that cool signature coming through from the east to the west, and then you can see that slightly warmer ocean temperatures off the west coast here as well. Okay, so we're going to fast forward now to when I started my bachelor's degree at the University of New South Wales. So I pretty much got into marine science a little bit, I would say a bit accidentally. I was kind of gravitating towards a science degree, but I really wanted to be a vet when I finished my high school, but that didn't really pan out. So I kind of decided to do just a general science degree, hoping that would guide me to, what I really would like to do further on. So I guess marine science kind of found me probably towards the third year and fourth year of my degree. So during the last year, which was like I had to do an honours year, an honours project, and I ended up doing a project on the red crabs of Christmas Island. This is an endemic species. They're terrestrial crabs. They live in the jungles of on Christmas Island, way offshore. Not sure if any of you ever been there, but it's quite a unique location and a community up there. And at the end of my honours project, I did end up going to Christmas Island to accompany another scientist doing a sabbatical. So that was, even though it was completely, hardly marine related, it was definitely an enjoyable project to do. At the end of my bachelor's, end of my honours, after I graduated, I ended up working as a research assistant on kind of small different projects, both at UNSW. And then I got a job all the way in England, in Yorkshire, at a place called the University of Hull, working with a research team that was looking at chemical communication in crustaceans. So this was an interesting project where we wanted to find out whether there was hybridization possible between American lobsters that were getting appearing in European waters. And we wanted to find out if there was hybridization that was possible between these two species of lobsters. And during my time there, I also was lucky enough to get the opportunity to travel and work with researchers in Norway, up in Bergen at the Research Institute there. And I also traveled for a couple of weeks to Boston at the Woods Hole Oceanographic Institute to use their labs there. And that was a fantastic year and experience and networking. So at the end of that, I came back to Sydney and I applied. I knew that I wanted to do a higher degree. And through my networking, I managed to get a mid-year scholarship to start a PhD down in Hobart at the University of Tasmania. The project I was doing was largely a fisheries project, so I was largely based at the Fisheries Institute down in Hobart, and my project was predominantly to do with the rock lobster fishery down there. So this project was trying to understand if to support the rock lobster fishery both in Tasmania but also across Victoria and South Australia. It was a translocation project, so we were moving these pale-coloured, small, slow-growing lobsters, that's what I'm holding up here. If we move them into shallower areas, into huge, big macroalgal habitats, would they grow faster like their shallow water counterparts? Would they change colour? Would they get bigger? Would they be more marketable? So that was my kind of PhD project aims that I did. What I probably forgot to mention in the background is the sea surface temperature anomaly map there. So again, 1999. So 98 to 2001 was a big major multi-year La Nina event, right? So this is back-to-back La Nina. So you can see how much of that Pacific Ocean is very cool, very blue. And then you scan your eye, because you can see how much warmer the west coast of WA was as a result. So, so again, that relationship holds between ENSO and ocean temperatures of WA. So, as I was finishing up my PhD, I hadn't quite finished submitting it. I applied for a job here in Perth with DPID, or the Department of Fisheries, that it was known back then. And I was successful, and I moved over to Perth in 2008, and I've been with the department since then. So that's quite a long time, almost 20 years now. And I'm predominantly based at the Hillary's lab, so very close to where you guys are, just down the road. And I joined the invertebrate trawl research team. So this research team is predominantly responsible for the science advice and research and stock assessment advice for the management of WA's scallop fisheries, WA's prawn fisheries, and also I worked quite extensively with the Shark Bay blue swimmer crab fishery. So a lot of my fieldwork and research, I was based in, I was making a lot of research trips to Shark Bay, and I've done a few trips out to the Abrolhos Islands as well. So we're going to now forward to the summer of 2010 and 2011. So 2010, 2011 was one of the strongest La Nina events that we've had in recent history. And you can see how strong that event was by how much of that Pacific Ocean is blue. It's like really strong anomalies, really cool anomalies there. But at the same token, you can see off the west coast of WA how hot it got, like really, really warm. To the point, these temperatures that we experienced over the summer is now known as that big 2011 extreme marine heatwave event. So this event led to the coining of the term marine heatwave by one of our late research scientist, oceanographer, Alan Pearce. And it was really the start of the research and knowledge and understanding of what marine heat waves were from this single point event. For myself, Shark Bay was essentially at the epicenter of this marine heatwave event. So water temperatures inside the bay was like 5 degrees at its peak above the average. During that summer, we also experienced some other climate extremes, such as a number of severe tropical cyclones went by either on the outside of the bay or through the bay. That resulted in some record flooding event of the Gascoyne River. So a lot of freshwater discharge and plume. You can see it from that photo there. The event itself down that southwest corner resulted in a number of significant impacts on both the habitats as well as different types of fisheries. So this included impacts on seagrass habitats, kelp, coral bleaching events. We had a lot of fish kills up and down the coastline. We had a lot of tropical species being found all the way down on the south coast. And then several months after the marine heatwave event, we started to notice the impact on the fisheries through declines in recruitment that led to some fisheries closing down their commercial activity. And so the two main fisheries that I was working on in Shark Bay, both the scallop and the blue swimmer crab, was those fisheries that suffered significant significant recruitment decline, and we ended up closing those fisheries for a number of years until the stock started to recover and reached a level that we could resume commercial fishing. So that was essentially how I came into this area of marine heat waves and understanding the impacts, not only on the fisheries that I was working on at that time, but more broadly understanding the impacts across the WA fisheries as well. So that's a big, long-winded introduction, I know, but I just thought that might be interesting to know how we kind of got into this area. So just to brush up on some terminology, because I know there's a lot of terms out there that's used in the media and in the general public, and we just want to understand, where does marine heat waves kind of fit into this? So just quickly, so three terms are climate hazard. So a hazard, it's essentially a physical event that could cause damage or disruption. So big ones that we're all familiar with are things like earthquake or a tropical cyclone, right? And then we have terms like climate extremes, which I've already mentioned. And as the term relates to, an extreme climate event is one that's kind of like well outside of its norm, and it usually has a statistical definition. So, like a 1 in 100-year event, or a heat wave that's a record-breaking heat wave that's exceptionally long, and we would usually call those kind of the extremes of that hazard. And then lastly, we've got climate disasters. So this is when either a climate hazard or an extreme event leads to loss of life, or loss of life plus significant damage to infrastructure or a major disruption to society. So that's, broadly speaking, that's when these individual events or multiple events can cause significant impact on our way of life, right? So in terms of that, when it comes to marine heat waves, simply put, a marine heat wave is just a prolonged period of ocean warming. So you can have like a number of days where the water temperatures gets really, really high. But when that becomes over a number of weeks or a number of months, in some cases years, that's a long event, right? So long event of extreme ocean temperatures. But it also has a technical definition, which is that at any given time or a location, when the ocean temperatures exceeds kind of the 90th percentile, so of its historical range, for 5 or more days, we then call it what we call a marine heat wave condition. And then if that lasts for a very long time, it becomes an event like this summer that we're going to talk about. Okay, so since 2011, when that term was coined, globally across our planet, we have seen a number of major marine heat wave events take place. So no two marine heat waves are ever exactly the same, and that's because marine heat waves can occur under different combinations. They have different characteristics. What I'd like to say is they have different flavours. So it's a couple of those. First of all, they can occur near shore, so hugging our coastline, or they can occur well offshore in the middle of the ocean. They can occur at the surface layer or in the subsurface layer, so they can occur across. So it's a 4-dimensional event we're talking about. They can also occur any time of the year. So you can have winter marine heat waves as well as spring, as well as summer marine heat waves. The duration can be quite variable. So by definitions, it's above 5 days, but they can last weeks, months, and years. So just to pick out a few on this map, so the Mediterranean Sea and the Atlantic Ocean, you can see the number of years that that region has experienced a number of times these marine heat wave events. And just like a tropical cyclone, marine heat wave events also have a category depending on its intensity. So you can have moderate, strong, severe, or extreme. And you can see extreme is that dark purple shading, which is what the one of Western Australia in 2011 had. So that was a Category 4 extreme marine heatwave event because the intensity was just really high. Okay. Marine heat waves can also co-occur or trigger other climate extremes, and I'll touch on that a little bit later. And it's important to understand that they can have both negative and positive impacts. It's not all bad. So depending on what population, what species, what location, some seems to do better or thrive under these warmer conditions as well. But most importantly, these events, these hazard or these extremes are increasing in frequency and intensity under a warming climate and a warming ocean as well. Okay, so let's step into this summer's marine heatwave event. Okay, so I know it's going to get a little bit technical with some plot, but I'll talk you through that. So right at the top, panels from September, October, November, December. So these are sea surface temperature plots. So the scale here just shows those darker shadings of red is just when water temperatures are increasing, where they're like 0.5 degree above normal to 1.5 degrees, to really strong anomalies are like 2.5 of the average. So you can see that shading. So right off in September, so pretty much this time last year, we started to see the Northwest Shelf region get warmer than average and warmer earlier. So a lot of this warming doesn't usually happen till later on towards summer, but it started that early warming. And then as we head towards November, you can see that shades of red getting darker and that footprint getting larger across the Northwest Shelf. And then by December, most of the Northwest Shelf, experiencing temperatures of 2 to 3 degrees above the average. Okay, so that's just visually looking at the maps, the sea surface temperature maps. But we know that marine heatwave has a technical definition. So that's what I'm just going to demonstrate here. So this is a sea surface temperature SST plot for the North Coast bioregion. All these squiggly grey lines represent the daily mean temperatures for every year for the past 40 years, so between 1982 to 2023, okay? And the blue line here represents how 2024 tracked. So that's 2024. I've just kind of highlighted in blue. The red line there is that marine heatwave threshold. So that's the 90th percentile. So any lines above that red line is when you're in the marine heatwave category territory. So you can see for 2024, start of September, that blue line is now creeping up and it's now lot above that blue, above that red marine heatwave threshold. And it didn't come down, it kept going up and up throughout October, throughout November. Then it kind of had a bit of a spike in temperatures around that early December. Then it dropped slightly below, but then it crept back up again, right? So it's a lot of heat building up across the Northwest Shelf, and SST anomalies were getting up to 2 to 2.5 degrees above average. Okay, so then we come into the start of this year, 2025. So the same plot, I've now added 2025 in that solid black line. And you can see that in the imagery up the top, we've got January, where that intensity is just building further up. And just along that Onslow Dampier region, we had inshore water temperatures that was almost 5 to 6 degrees in that localized scale. Water temperatures was really increasing. But just as we were heading into February, the monsoon finally kicked in up north, and was very late monsoon start last summer. And we had a series of tropical cyclone systems that started to enter our state waters. So I've just put the names of those major tropical cyclone systems that came through. So the big one, of course, was Tropical Cyclone Zelia. It was Category 5. It was really slow moving, churning up and coming through. Thanks, Cecile. As these tropical cyclones came through, you can see there's drops in these temperatures, right? So you got some systems come through, the sea surface temperatures drops down a bit, then it creeps up, then we've got more systems comes through, and then it drops down. And then around March, that blue line goes well below that red line, and we can see that's the end, pretty much the end of that marine heatwave event for the north coast. And I've just provided a little bit of summary of that. And just to kind of touch on the relationship between marine heat waves and tropical cyclones. So these two extreme kind of events are going to co-occur, particularly for our North Coast region, pretty much every summer now. And this is an image showing all the tracks of the 12 tropical cyclone systems that developed over the last summer season. Most of them was off WA. Most of them was well offshore in the Indian Ocean. We, of course, had only a few systems that crossed the coastline and ones that came close by. Now, tropical cyclones really feed off ocean heat, and they can occur when no marine heat waves are present, but of course they're a lot more fueled when there is hot ocean temperatures are quite high. But as they go through a region, they also help cool down the system as well, as we saw in that plot below. So it's a bit of a love-hate relationship with these two climate trends. So I might just skip this one. So this is just a short animation showing how much that cooling in that surface layers along that track when tropical cyclones move through. But given the time, I might just skip over that. Again, this is kind of like a before and after sea surface temperature map. So there's the Northwest Shelf before Zelia came through. There's the same map after Zelia, and you can see how much cooler that top ocean has gotten because a lot of that's been sucked up by the tropical cyclone system here. Okay. Now, moving away from the north coast, this marine heat wave also then started to travel down the west coast. So coming down the Gascoyne and down the west coast. So this first panel is the start of January when most of that heat wave event was happening up north. And then by the end of January, you can see a lot of that heat wave and heat wave conditions have now hit the west coast. So that dark red shading is when water temperatures were about 3 degrees above the average for a typical January. And one of the main drivers of that heat coming down the coast was this surge in the Lewin current, right? So this Lewin current, which just usually tends to be a bit weaker off summer, but because we had a bit of a La Nina situation developing in the Pacific Ocean, it really kind of triggered that, the strengthening of that Lewin current, bringing a lot of that heat down the west coast. And then about a month later, you can see that heat intensity has backed off, but we still had marine heat wave conditions persist. Coming further down to the south coast, very similar story. Start of January, the heat wave was, just a little bit, backed off. But by the end of January and February, that marine heat wave has really well and truly hit the south coast, really facilitated by that surge in that Lewin current. And so you've got warm ocean temperatures both near shore on the shelf, but also offshore in these eddy fields as well. Now, if we looked at the south coast temperature plot, that looks very different. We're not going to have the influence of tropical cyclones here to really cool it down. What we do have on the south coast typically is strong southerly winds over the summer months, but that really didn't occur over this summer. So we did have some periods of time where the southerly wind really kind of picked up, but it wasn't sustained enough to really cool it down. So you can see for the south coast, that black line, which represents, 2025, was largely above this red line for a very, very long time. So overall, for the south coast, this marine heatwave event almost lasted a whole year, 361 marine heatwave days between 2024 and 2025. And this temperature plot, anomaly plot here, you can see this orange bar. So this orange bar represents is the mean average temperature for, summer for the south coast. And it's well and truly the warmest summer that South Coast has experienced, well above broke the record of the previous one, which was 2013. Okay, so just trying to think. Okay, so just in interest of time, let's quickly go. I'll touch on this. So this is a lot of the information I presented is the surface, the sea surface expression of marine heat wave, and this particular marine heat wave was also extended throughout the water column. So one way that we try to understand what is the subsurface ocean condition during a marine heat wave, you can do this by deploying a range of instruments. And one of the key instruments that we had put in the water to understand is the ocean glider. And so this glider just takes these dives in the subsurface, and as it's going through the different depth layers, it takes all these measurements, temperature, salinity, chlorophyll, and it sends it back. And so you can see all these shades of red that relates to temperature from 0 to 200 meters really shows at how deep this marine heat wave event was below the surface. So it was hot on the surface and was definitely hot below the surface as well. So just to kind of quickly wrap up some of the key drivers of this marine heatwave event, we're still trying to understand this event. I mean, it only ended a couple of months ago. So, researchers from different disciplines like physical oceanographers and biologists and ecologists still trying to understand how hot and long this marine heat wave was. And one of the key kind of driver of this event that most agree is the changing climate, the warming ocean. So for those of you that are probably not aware, 2024 was the warmest year on record across the globe. Warmest year in the ocean, warmest year on land. It was the warmest ocean year around Australia, and it was definitely the warmest ocean year for WA. So all those records are breaking. That means there's a lot of heat just sitting in the background of WA. So all that kind of really requires is then some of those seasonal and regional influences to come in to kind of create that big heat wave event. So some of those drivers were that weak La Nina, not a strong one like the ones I've showed you previously. So weak La Nina came through. That triggered, that stronger surge in that Lewin current to bring even more warm water on top of what was already a warm ocean. Then we had a kind of a late monsoon, which allowed for more heat to kind of, build up. And I guess lastly, all of this happened over summer when our ocean temperatures are already at their maximum. So you can see how all of those influences kind of come through the perfect combination to create a big marine heat wave event. I'm not going to talk too much about the impacts, but I will say one of the most defining and significant impact of this particular marine heat wave event has been the significant bleaching and coral mortality that has already been reported for Western Australia. So this is the worst one that Western Australia has ever experienced. So coral reefs and coral ecosystems all the way from the Kimberley all the way down to Ningaloo has experienced some extensive bleaching. And this is some of the photos that demonstrate that, and some of the media attention and outlets that have documented this, the extensive bleaching that has taken place. We also had a big fish kill on the Pilbara coastline, but we didn't see a lot of fish kills like we did with the 2011 event, and there has been some impacts on the fisheries, but maybe we'll just keep that for another time. Okay, so I did want to kind of talk about initiative that Fisheries DPIRD is doing, and that was these marine heatwave events. Like I said, under a warming climate, they are going to increase in frequency. So we're going to see more and more of these events and more intense events. So how do we better prepare? How do we better communicate? How do we better respond to these events as they occur? And one initiative that we're doing is we've just developed a marine heatwave response plan, and this response plan includes things like monitoring the ocean, understanding the risks of when marine heat waves are likely to occur. It includes some forecasting information. This plan also kind of has a guidelines around how do we communicate this with the public? How do we communicate these events and its impacts with our stakeholders, with our license holders, with other state agencies, with people like yourself, who will have a lot of questions, especially when these events have significant visible impacts like bleaching, but also when we have fish kill events up and down the coastline, and then the flow-on effects onto our fisheries and tourism as well. Okay, so this is my last slide, but I just wanted to mention that recently, a week or two ago, the Australian Academy for Science released a report that kind of highlighted 8 key areas where science capability is really needed into the future. And 2 of the areas they identified was climate science and data science. So for those of you who are in the classroom and else listening in, within marine science, there's a lot of areas and research you can get into. But I would really hopefully have kind of, convinced you that the area of climate science is going to kind of dominate your generation. It's already dominating my generation. And there is a big need to increase our capability of understanding climate science, and that's going to kind of merge climate science with other types of science as well. And climate science is underpinned by data. Like data drives a lot of this climate trends. Projections, decision making, and it's going to impact every single aspects of our lives going forward. So if you're thinking about a career in marine or in science in general, maybe think about climate science as something you want to kind of work towards.